All right,
Hello, Mr. David.
Mr. Christian, pleasure to see you.
Okay, since this was your idea, what are we going to do?
So, since I don't know if you have known, but there's a new JAX version on the street, and I would love that we can do a small tour of all the things that are so cool in JAX. So I know that it's already deprecated for Python 3.7. So I don't know if we can have a tour of what's new.
Who uses Python 3.7, David?
Oh, I have I don't know if I ever told you, but I have some legacy code I have to run on Kubeflow that it's pinpoint 3.7 because protobuf on Google.
Okay, so I think what we can do to give some context for people who don't
Mm,
know is just go through like the basically JAX 4.0 features.
mhm.
And then I had been playing with it this week, like preparing for for maybe this idea.
Right.
So we can play with, like in a notebook with. Um, so I have a TPU, so we can actually
Oh, cool.
uh,
That's cool. It's a B2, B3, TP pod
V3.
B3.
So
Okay.
so
Okay, that's good.
so we can actually play with this. I think you can also play on CPU, but well, I already have the environment set up. So
You're sharing the complete screen. I don't know if you want to maximize the.
yeah, sure. Is that I just wanted to see the faces before digging in.
Gotcha.
So okay, let's see. No, maybe too big.
Yeah, I
Let-
think a little bit plus. Can you
Okay,
give a little plus? Okay, yeah, that's great.
I think this is fair. Uh,
Hmm.
okay, so what is the big thing for JAX? Maybe the JAX migration guide tells also a little bit of the story.
Hmm.
Uh, Basically, in JAX, you used to have like many array types. If you created like a simple array, you got a device array, and then depending on what you're doing, let's say uh, if you use PMAP, uh, then you got like a sharded device array, and I think the global device array. I've never used it. Not sure if that's what you get when you use pgit or maybe even running on like a multi-host environment.
Hmm.
I've never used this one. Uh, but yeah, I think this one is for multi-host. So that okay, that's how things work. But then you had different array types. Uh, so what this new type wants to do is just basically unify them all. So there will be only jax.array as a single type. I guess this cleans internals, uh, and you don't have these differences.
Hmm.
Uh,
Is
okay,
this just a small question? Is this related to the talk of Matty Johnson in the GTC, the
yeah,
NVIDIA GTC talk?
Matt's GTC talk was exactly about this.
Okay, perfect. Good to know.
Now it's materialized, and we can see um, the results. And
Right.
actually,
But
no,
you sure you don't want to finish that part of the JAX array migration?
I think the important thing was here. Then it
Hmm.
tells you like how to enable it and other stuff. But that is we're already on 4.0.4.1, so it's enabled
So
by
it's
default.
enable. Okay, right.
So okay, it's kind of a unification, but also introduces new APIs. So as we will see here, the APIs is that now like arrays. All arrays have a dot sharding field or property
Hmm.
that uh, basically defines like the layout that the array has. So the array is in a single device, as we can see here. It's super
Okay.
boring. It just tells you the whole array is just on uh, TPU zero. Well, yeah, basically, um, it's on a single device. Uh, but the nice thing of the API, well, is that it makes it a little bit easier, or rather transparent. I'm not sure that it will be entirely like trivial. Maybe we can play with it and and see
Yeah, figure figure out if it's a leaky abstraction.
how easy it is. I don't think it's leaky, but I don't think certain things are easy to do, or maybe you. Yeah, I don't know how to do them yet.
Hmm.
On the background of this is that basically what this does is that some of these abstractions existed for Pidgit, and what it's doing is that now basically it's like if you have Pidgit everywhere. That's how I interpret this change. Um, well, the interpretation they give here is that JIT equals Pidgit, but since all low-level functions from JAX are JIT, in my mind, then that implies that it's PJIT everywhere.
Okay.
Uh,
So that means
so
that the JIT is done in each device, or is globally, and then somehow this compile, it's done in each device with PGIT like that.
something like that. What it means is that every operation
Hmm.
before, even if you run on eager mode, every operation was JITed.
Hmm.
Now every operation will be JITed, but now JIT has the same power as Pidgit. So uh, now we have the properties of Pidgit everywhere, and the properties of Pidgit include being able to run in um, like operate over distributed programs. Obviously, this is it will be transparent if we do simple examples, because
Right.
now the arrays carry the sharding, as we will see. So since the array contains a sharding, you can use, well, pgit will read that metadata, or uh, well, the I guess low level infrastructure, because we will not be using pgit, and then it will be compiled into a distributed program. So
Cool.
if we look at this simple example, the idea is that you create like a sharding that is uh, so you have to create like like a mesh. So you have certain devices. For example, TPU has 8, and then with that you create like a sharding, and that sharding has a nice API. It behaves like an array itself.
Cool.
So it has like reshape and other utilities that you can use to give it a shape, and then once you have that, it's you use the API from JAX called device put, and then it basically shards your array. That's kind of what's going to happen.
Perfect. And what
So
is the type of what?
the type
It's
of way, uh,
JAX Array.
well, now everything is JAX array. There's
Okay.
nothing that is not a JAX array. Uh, the main difference between x and y is that x, well, we can visualize it. We can tweak this. X will be just in TPU 0, and then
Hmm.
y will be in this in this arrangement. So it's still the same values, but they are distributed over multiple devices according to this shape. So the first dimension will be split in four, and the second dimension will be split in two. So yeah, I wish we could have like a simple example where maybe you can uh, easily show how the values line up here. But yeah, just imagine breaking them into multiple subarrays and then sending each subarray to
To each device.
to each device. So that's kind of what's going to happen. So we go to the. Can you see?
Yeah, I think that if you can augment the font, and I think we
Oh,
don't
sure,
need the
sure.
file system. Yeah.
Okay. I was doing this in a Python file, but I think it will be way nicer in a notebook. So let me change to notebook.
Hmm.
Um, so okay, we want to do a couple of stuff. I already have this with poetry, so poetry shell. Uh, Maybe we can post the repo link in the description of the video
All right.
for future users. But um, so since I was playing with this, I had to use the flag. Let's just update JAX. Pip. Uh, so I guess let's just do some updates. So we're not using pip poetry update. Let's see what happens.
Oh, updated. That's cool.
I think I have to install the TPU version. Let me check
Ah,
what
the
happens
TPU
here.
lib. TPU lib.
Yeah, I might have to do that. Let me just check what happens here. Jax.devices. I might get CPU 0.
Oh,
Oh,
that are the
interesting.
TPUs.
Interesting. Why?
I think it's the TPU lib should be compatible. But let us see if it breaks while doing the shrouding. Maybe that.
uh, yeah, I don't know. Usually I had to do this.
Sure.
Not sure why it's reading the TPU directly. With this is nice, but not
Perfect.
expected. Just one sanity check. Okay,
Yeah.
okay. I'm not sure why this is happening, but it's all good. So okay, first thing uh, we want to do maybe. Uh, Okay, so these are kind of the imports. Okay, so we're going. Okay. Um, let's see. Let's do it the easy way. Uh, which is similar to what they have in the tutorial.
Yeah, so we're going to do it just for one dimension, I guess.
Yeah, well, in the tutorial they do it for a 2D array.
Hmm.
So uh, maybe we can do something like arrange and then 64 times 64. 64 times 64 and then reshape. So we can have some simple 2D data like this
Hmm.
to start with. Okay, so first thing we can actually do without is visualizing the sharding of this, and okay, it's TPU 0. So
So it's
this
only
is,
using the first device.
yeah. Second thing you can notice,
Hmm.
uh, well, if you inspect this, X has a sharding. X has a sharding property now, and
Hmm.
it gives a single device sharding. It seems there are many type of these shardings. Uh, Here we will create a new one, positional sharding. I've seen PMAP sharding, so it seems it's not like a single type, but it's just kind of an interface. So okay, this sort of describes where our data is right now. Like it's on TPU 0, and this is kind of the TPU device, so it's just on a single device. Um, so okay, this is the part where uh, I guess we do something a little bit more interesting, which is okay. Let's create a sharding. Actually, let's create a sharding by itself, um, and then see what we get here. So
Mesh utils create device mesh that returns. So what exactly does this? This positional sharding. What is the signature? What is
uh,
this object behind?
it's a good question. I think it's just gonna return an array of devices. Yeah, this is very similar to what you get. I don't know what is the actual difference if you use jax.local devices. Get this. Let's try
Hmm.
to change it. This makes more sense for me. I wish we could ask Matt what is the difference, but it works. So
Yeah,
maybe we can simplify it like this.
because my guess is that this positional sharding, like behind the scenes, is actually doing JAX and I don't know device put, and then depending on how the configuration put in here like slices of this array.
For now, this just says pass me like a list. It says a sequence of device.
Hmm.
Yeah, so we can do use local devices, and then it just gives us a structure. This structure kind of defines the mesh. So you can do things like reshape. So I don't know. Since we have 8 uh, devices, there's not much we can do except like
Uh,
2 by 4, which would be like a different combination. So
hmm.
uh, yeah, I guess if you put something that is impossible, it will error. So
Yeah,
cannot be
because it
done.
need to the reshape needs to that the multiplication it equals the number of device, I guess.
Yes. So
Cool.
this is a thing. Uh, I was also curious what
Hmm.
happens if you go crazy and put more things here. Let's say this is false, but what if we have 16 and then
Can
I
you
guess
comment the reshape? Hmm.
4 by 4.
Number of devices, eight must be. Yeah, so it checks. No, wait. Can you go back to the error? Because it fails on the reshape. Ah, no, it fails on the positional shrouding.
And a position sharding. Okay, so it does like a sanity check
Hmm.
to see.
Makes sense.
Yeah, so we just don't put an arbitrary number of devices which we don't have.
Hmm.
So might as well just use this. Uh, so yeah, here we don't have like a lot of options. I guess 8 by 1 is an option. But yeah, in that tutorial it's 4 by 2. So let's just continue with this. Um, so this our distribution. I think TPUs are are structured this way, where you have a four, I don't know, four things connected 2 by 2. Um, I believe that's how the architecture is implemented. I mean, I don't know for sure, but I think I read it somewhere.
So does the shape of your mesh will benefit if you know the topology of how that thing is structured? Or
Mm,
I,
it's
I
let's
mean,
say
I will be surprised, like if depending on who you shroud. Okay, but maybe we can take a look.
yeah. If you see these coordinates,
Hmm.
there is 0 0. I don't know why there's a third dimension. Maybe future TPUs will be cubic. But if you look at this, you have a zero
Yeah, in the chord.
zero, and then the next one is also 0 0, the coordinate. So it seems that they're together, like 0
But
and 1
it's
are together.
yeah, because look at the in the sec in the last parameter there is core on chip, so the second chip of that in that coordinate,
Yeah.
I guess.
So it seems they come by 2,
Hmm.
uh, according to this. So maybe it makes sense something like this. And that's why the examples are like this, because this is optimal. These two are close together, and then all of them are with their pair here. Uh, so so okay. We don't need this. This was what I was playing with. Okay, so okay, we're not actually doing the reshape here. This is just for understanding.
Hmm.
This does not mutate sharding, so like the original sharding, we're not touching it. So we do it again here. Uh, I'm not sure why. Like if you're just gonna have a single sharding, you just could even do it like this, I guess. Unless you want to get creative, or this may be so you don't have to recreate it over and over.
Hmm.
What happened to the sharding? Oh, it's here. Yeah, maybe it's like a nice strategy. So like create one sharding, and then um,
Yeah.
depending on the array, you change the sharding a little bit. So might be like a good strategy. So yeah, let's leave it as a tutorial. And then here, well, we're gonna use exactly this sharding strategy of 4 by 2.
Hmm.
And the awaited moment is that we we get y in, well, distributed in the 8 devices. So it's more or less
The
what
same as the tutorial.
the same, yeah, the same as the tutorial.
One question though is there any chance that we could see like, look, these two elements of this vector are in TPU 0, this one on TPU 1?
That would be nice, but Jax makes it transparent.
Mm-hmm.
So if you just plot the array, you will not see anything that uh, has that. I don't know. There might be like a secret API. Let's see if there is something like value. What is value? No, value is just the thing we get here.
Mm.
Um, I'm not sure. It would be nice to have some of the Jax core members. But okay, so well, I mean, this is also the beauty, right? You don't care
Mm-hmm.
where they are, and you can just visualize them. It sends them to the host, and it prints them. Very nice. Uh, so one of the big changes, at least for users, I think will be that previously, if you had like a, let's say, a sharded array, maybe the sharded device array, which was kind of the name. Um, you had to be very aware that you had one of those objects because you could only use them inside a PMAP, for example. And if you were to operate over that in any way, like let's say either eagerly or you pass it to a non PMAP function, it would send it to a specific device. It would alter the sharding basically. Uh, so the nice thing that we have after this is
Mm.
that we can do, and this is going to be the most trivial operation. Um, we, we can do some simple operations over our array. And okay, first of all, oh yeah, we get the values, but then jax.debug visualize the
A still
sharding is
shard.
kept.
Mm-hmm.
This is kinda, I think this is the main feature in my mind. I think this is the feature users will enjoy. Uh, you can operate over a distributed array very simply. This is very nice. I mean, as I've been doing stuff with Jax, I've had the problem that yeah, I had a pmapped structure, and then I did an operation. Let's say I passed that structure through JIT,
Mm.
and it's very easy to forget. Like, all right, like even though let's say I was gonna do a per like an operation per value, uh, like
Oh no,
pointwise.
sign point sign. No?
Yeah, I was gonna do like a pointwise operation. So like it really like yeah, it wasn't well. I mean, I had a code that was using JIT, and then when you're gonna do pointwise stuff, you usually don't think you have to create the distributed version. So when uh, when I did it, there was kind of a silent bug, which Jax. I mean, it wasn't a bug. It's just that in that case, what happened is that the sharded device array was converted into a device array.
So it was sent back to the host, I guess.
It sent back to the host or device, the default
So
device,
mm,
device 0, and then the operation was done there. Since the array had the same shape, next time I did pmap, it uh, distributed back
one.
to its to its yeah, like it had Jax has sort of a shape based API. So it didn't break my code, but it was breaking my memory. I was getting a memory bug. Um, because I wasn't expecting all of the parameters to be sent to device zero, and if I chose like a very uh, low batch size or small model, everything was fine. But as soon as I started growing it, I started noticing some out of memories and pinpointed it back to, oh, okay, I'm using JIT here, but I should be p mapping. I should be using
Before.
pmap.
Hmm.
uh, Now that won't happen, and it's very cool that if you're just going to do point-wise stuff, uh, you can use JIT. So okay, we did this eagerly, but let's just for the conversation, uh, let's pretend uh, we're going to do exactly this. So let's create f, and we get like a value, and yeah, let's just do +1.
Just to the state of change, can you do, I don't know, sine of x, cosine of x, maybe?
Uh, uh, okay. I thought this was easier to track because they just increment by one, but uh, yeah, no, let's keep doing. Let's do -x. Uh, so I don't know. Let's put a new variable a equals f of z. Uh, so z, well, has this partition, and we have a JIT function, not like a pmap or pjit function. And the thing we should expect is, okay, well, we get our values, but
Can we
JAX
take a look at the, yeah, visualize sharing? Cool.
sharding didn't change. So this, I think a lot of new users face this. Like, I've talked to a couple of users who are starting to use pmap, and then they did something eagerly, and then like you have to explain them like, no, this will send it to the to the host, don't do that. So um, yeah, this, I think it's a much better API because it simplifies things a lot in my mind. I mean, the types are unified, but also the user experience is a little bit unified. You can
Ah,
merge.
Christian, we have a comment from Josh that says that create device mesh, return the most performant ordering of device given the shape.
Oh, nice.
Yeah.
So
And yeah, and Diego, we are using VS Code remote to a machine that has TPU, so that's why we're using we can access TPUs from a local IPython notebook.
oh yeah, yeah. If you're wondering why I have a TPU, uh, because VS Code remote. Okay, that's an amazing explanation of why we should use this. So it's pretty interesting that this actually returns
The most efficient.
the most efficient, but
And it was two columns for rows, right?
the most
Well, it's not.
efficient is a little bit different to what we were speculating at the beginning.
No,
So
but can you create with mesh? Because it looks, for me, if I recall correctly, was ordering uh, four to like.
uh, yeah, let me show you. This one is like very orderly, and this one, as you'll see here, I think something's changed. You have four and five here, six and here, two, three. Uh, okay, they're still very similar. It's just that this row is swapped with this one.
Hmm.
For some reason.
Can you put again the coordinates? Maybe in the coordinates you can see it.
The coordinates, what I did up here.
Yeah, so it was, what is the ID that's supposed to be switch? 4 and 6? Look, 4 and 7.
Uh, okay, but this is what I did here. Yeah, here.
Zero,
This
one,
is
two,
kind of
three.
the linear version, right? The other one we
Hmm.
reshaped it, but this is the linear version. I guess. Yeah, but four and five are here. Let me just check.
Yeah,
Yeah, no, you
four and
got
five
four
are
and
there.
five. So it's kind of the same, just that four and five here at the end. Not sure. Maybe maybe somebody can explain in the comments why this is better. So, but that is nice to know um, that this is optimal.
I think we should add that to the documentation.
Yeah, yeah. I have a couple of tips to documentation. I'll mention to all has who is working on documentation.
Hmm.
Um, okay, so where were we? Yeah, we created a JIT function, and the JIT function was able to operate over like a distributed array. We mentioned that this might help catch a couple of bugs. So let's see, we can do two things. One is continue the tutorial. The tutorial has a lot of examples. I don't think in the time we have here we can cover all of them. We already kind of saw this. This is just using different shardings. Um,
Cool.
there was one thing I was trying to do the other day that I don't know how to solve, which is okay. There are two ways of doing this. Let's view the other way. Um, it's with uh, the other way is using name sharding. Uh, I think we should view this. I think this is a little bit more flexible, like position sharding. It seems that we're like hard specifying where everything went. Here, it behaves more a little bit of how the signature of JIT and PJIT behaves, where uh, especially I've seen you can pass nonce or omit something, and then it implies replication. So let's view this other API.
Hmm.
And I know that some of this is used for doing like PG programs. So I think yeah, I'd be very curious to what use case positional sharding has. Um, because one thing I was trying to do, let's yeah, let's speculate a little bit on what I was trying to do, and
All right.
let's view this other API. What if X? Let's say we had. Let's create a new variable T. So what if T is X reshaped, but so we had a 64 by 64, right? What if this is something like uh, 8 by 8 by 1, right? Like usual data you have.
Mm-hmm.
So my main question was Okay.
It feels
Okay.
sweet.
Yeah. You cannot visualize things that have more than 2 dimensions. Uh, but it's fine. My question was, how do I shard this using the positional sharding API? Um, and if we try to do something like this, it doesn't work. Uh, because like we need to have the same dimensions as the number of, so t has 4 dimensions, but the sharding will have 2 dimensions. So uh, we can check that it doesn't like what we're going to do. So we can try to put t, and let's
Yeah.
link k. uh, like yeah, this, let's just show it gives an error, like it doesn't like it. So I was thinking, okay,
Assertion error. Hmm.
how can I put this type of data? The only thing that occurred to me is leave it 64 by 64. So this is what we had previously. uh, 64 by 64. Put it here, and then reshape k. But the thing here, I don't know if this will be correct. So we can do it. Like this works. We get k. We
Oh,
but
it worked. Hmm.
it works. But if we look at the sharding of k,
It should be.
it is very. I did not understand this. Like it says okay, 1 2 3. I mean, I don't know if it is a representation bug. Like, why is there a list beside some numbers? Uh,
And it's of
yeah,
type of sharding, right? So it should be.
up,
Yeah.
up.
What was the?
I mean, that is a new sharding, but I guess there's many sharding types. That is not
Hmm.
my main concern. My main concern is how is this actually sharded? This is I don't understand this. I don't know. Does somebody? Yeah,
Nope. Nope.
nobody knows. So I don't know. And as you were saying at the beginning, like I don't see a way to discover how how this is sharded.
Hmm.
I mean, ideally the sharding would show me like a nice print. I don't know if it is a bug, uh, and we're missing something, but uh, yeah, I don't understand this representation. So we have the problem of not knowing how this charted. Ideally, it keeps the same sharding. Uh, like it splits this in four, and then it splits
The responsive.
each of these in two, and then this one it's kind of an imaginary, so it doesn't do anything.
Hmm.
So okay, my wish was it like the values are in the same places because this is just a reshape. So they're in the same devices here. But then, for example, on this dimension is the 64 is split, it works. But then on this dimension, like the other
Yeah,
these
there are like 8 permutation in which they can end up, I guess.
yeah, so I would split them in this, and it's hard to think about it because, but yeah, ideally like something like, okay, the first 8 end here, and then the other end here.
Oh no,
So it's hard
I
to understand, but
I will expect that there is like code that minimize the number of of copy numbers that goes along the that goes around to avoid copying a lot to devices, right?
yeah, for sure. My but my wish was, okay, like split in this dimension, like as we were doing, and then in this other 3 dimensions, split it in the second dimension of the
Hmm.
sharding. I don't know if that's what is happening. It's unclear. So
Hmm.
uh, even worse. Okay, let's pretend we have something simpler, like just 8 and 1, right? So this is like a data parallel program where we have like the batch dimension and then the other dimensions. Let's see what happens in this case.
8111 and then a list.
Yeah,
Wow, makes sense.
devices. Mm, no, I'm
Um,
not sure. At least there's like 8 and 1, which is what we have here, but not sure what is happening. Ideally, we get the same as we would get like in a PMAP, which is that, yeah, on this dimension it's split in the 8 devices, and then these other dimensions are kind
spread.
of replicated
Hmm.
because, well, I mean, well, yeah. So they're not split. We're just splitting on the first one. Uh,
They are they are copied along the second dimension.
so how you can solve this, if you actually want to do this, is you you create a like a PMAP function. I mean, this is just the old way of
That
doing
sharding,
this.
there is just told us that we can use addressable charts, like try k addressable charts. There is a method on k that is addressable charts. And
Oh,
that sharding
interesting.
means that the first dimension is shard 4 ways and the second dimension is shard 2 ways.
Oh, wow.
What?
That might require an
Yeah.
explanation,
Huh.
but
Oh, cool.
let's inspect addressable shards. Let's see, it's a little bit long. So I'm guessing this is how our data is actually positioned. Well, okay, we have the data. Is this is a like a big structure, so maybe we don't want to view the data, so we only care about the okay, okay, it's more explicit chart device, uh, and then
Oh, the
we
data. Okay.
have a slice. This makes a little bit, this makes more sense. uh, and then what property is this? Yeah, I wish we could get rid of the data part. uh, let's see, does this have another field? Clear, extend, append, pop. Okay, it's kind of a list. Seems this is a list. Okay,
No, it gets the data also.
it gets the data, but here we have all the shards. Would be interesting if this has like a shape, but it probably doesn't. Let's just see the length of this. 8. Okay. Curious what we get if we do the 4x2. Okay, we also get 8. So this seems to be the how the data is actually split. I don't know if Yash can can comment. Okay, I'll be looking into this more. Yeah, question would be if you're doing a data parallel program, you if you do this hack that I'm doing here, you get the same as what I'm about to do here. So what I'm about to do here is we're running out of letters. K, P. So let's. So if we p map this, uh, because I already did it. Okay, we first let's not pass t, but pass t reshaped. What we had up there. I mean the final value. So here, because I know how PMAP works, I know that it's gonna be split into 8 on this axis, and the other ones are replicated. Uh, so if we print charting, we're gonna get a special type. So let's just do this. Uh, replicas 64. Only 8 devices. Okay. Yeah, we have to put the number of devices. So 8 by. Oof, yeah, a lot of 8s. Let's just put a 64 here. A little bit different. But so let's just let's just put what we have. So we map is very specific. You get your batch dimension and then you split it into like the super batch dimension. I guess that's what I call it. Sadly, we have a lot of 8s here. I don't know. Let's put like a 64 here, just so it's not so boring. So we split the batch dimension into the super batch, and then this is kind of our device batch, and this is how we do it. And it's easier to interpret because you know that it's going to be split on this dimension only. So I mean, very similar to what we had up there, but we did with a reshape. Here we're doing it with the properties of PMAP, and the output we get is called p sharding, and it's kind of a very different structure. Uh, I guess it just says I played with this before. It says okay, you have this unstacked on this dimension, and then the other 3 dimensions there's no sharding. Uh, so that is kind of a little bit easier to interpret. And then it says that the sharded axis is 0. So all this makes sense. Uh, very curious if this is somewhat similar or equivalent to what we did here, where we tried to data parallel, but then we sharded it, and then we tried to reshape it. Uh, but yeah, we got kind of the data parallel program this way. Um, so I don't know, David, should we leave it here, or do you want to view this thing of the partition spec?
Hi,
David.
I yeah. So there are a few things that I wanted to say. I still not clear about. Can we do the example of the name shrouding, like associating names to each shrouding?
Okay, yeah, let's do the name sharding. So yeah, for the name sharding, we're gonna use the partition spec.
Mm-hmm.
Um, I know that this before was used like in Pidgit programs. um, and the big difference is that we're going to give names to the dimensions we're going to be creating. Also, a little bit curious of why we create like a mesh object, and before we didn't create like any mesh object. Uh, like to create the original sharding, we just create like a sharding. Here we create like a mesh, so it's a little bit different. Um, yeah, this resembles more how you do things with Pidgit. So yeah, we have the devices. Do we reuse devices? No, let's just use here. So here we're gonna okay, we're gonna reuse the same function we're using, create a mesh.
Then you
But then
provide the access name.
the big difference is that we're gonna say, okay, in this mesh, the first dimension of devices is going to be named A, and then it's gonna be named B. And then like we're creating well, this is just an alias for the partition spec. So I guess it looks nice if you're gonna be doing this a lot. And what you're gonna do is that you're gonna use the name sharding. So I would love to actually just uh, call this sharding as we were doing it on top, and let's just see what we get here, and let's just put this down here. So let's see what this sharding looks like.
So
Okay,
mesh ARB. Mm,
so it just says mesh A, you have 4, and B, you have 2.
yeah. So
And then you have the spec, which says that you have the names A and B. I'm a little bit curious what happens with the devices. We're not seeing the devices here. Maybe they're hitting like under
addressable devices.
addressable devices. Okay, yeah, they're
Yeah,
here.
they are there.
Uh, but it seems that this representation is a little bit more abstract. I mean, it assumes we okay. We pass it directly, so we know it. We know the mesh shape, I guess.
Hmm.
So we're gonna have this sharding. In this case, let me just do silly stuff. Can we reshape this one? I don't think we can reshape this one. So this is a different type of mesh. I guess this name. Can you rename it? Uh, mm, device set. So it seems the other one had like an API that you could use to reshape it on demand. This one
Doesn't have anyone.
seems to be a little bit more static.
Hmm.
What do we get here? get an error. We're missing global shape. Mm,
Mm,
let's see.
8-1, 8, no, 4-2.
For two.
Yes.
Okay. This I don't know what this is, so let's just continue. Um, okay, so let's put a device on this sharding and do the same that we're doing.
Cool.
So okay, we got the same. Uh, seems that
But
a trick that you see in the documentation that is actually okay. Since we cannot reshape this type of sharding as we were doing with the other one, we just kind of just reshape it. The documentation suggests more do it like this, or actually they suggest create like a helper function. So I actually don't know how much this buys you because
I
it,
should
it's it's still just forwarding to name sharding. Is it actually
just validate
okay?
that it's not none, and then
Yeah, it's just doing some validation. Sure, maybe some examples look a little bit nicer
Mhm.
because you can decide not to pass the mesh. So they just pass. Ah, well, they create like a default mesh, which is a mesh of the devices in this configuration. So this is just kind of a, a default
I
thing, but this is very similar. We just keep the mesh that we have here and start. So this is other stuff you can do.
let
Because
us
this
switch the
already,
name of the access. BA.
yeah, that's what they do in the documentation. So they say, okay, if you wanna transpose the arrangement,
Cool.
then you do BA, and then
You can
you,
also use none. So if you only have like, you can do A and none, B and none.
yeah, exactly. So this would be equivalent to what we didn't explore that API. There is a replicate API for the positional one. Maybe let's just view that trick.
Hmm.
Uh, let's go to the simple case. So I think it's very similar. I'd be curious if the other one is more powerful in some way. But when we were looking at this, you can also do this type of.
I think you got beaten by variable name.
Okay, we have to recreate the positional sharding.
Hmm.
So in this one we can also do the same trick. So we can transpose it like this. So this is the same we had there. Uh, the trick we're going to see later. Let's say we have this one. We can also replicate over an axis. So if we replicate over the axis 0, we're gonna get okay.
How come? What
No, no,
does this mean?
I wasn't expecting this.
Uh,
Uh, let's see. What do you get with the axis 1? Why does the axis 0 collapse all of them? I was expecting a different result actually. Uh,
huh.
okay, no, maybe. Okay, obviously there's no axis 2, so this is an
Yeah,
error.
yeah, makes sense.
So okay, it seems that replicating over the axis 1, what it does is that okay, it fuses it in the dimension where you replicate. you sort of well, you merge them, right? But I was expecting in the axis zero, in my opinion, unless it's just a color thing, the axis zero. Is it just a
Zero,
color thing?
0, 2, 4, and 6 with the same colors.
Why
Actually,
does it have the same color?
can maybe in the documentation, because in the documentation you don't have the colors, you can see those things. Yeah, and
Oh,
maybe
yeah, yeah, yeah.
inside. Yeah, look at this.
Okay, yeah, yeah, it's the same thing we have, but here the color makes it super confusing.
That was cool
A
to
color
figure out.
bug.
So
Okay, we have a color bug here. Um, okay, so yeah, this one just squashes basically the
Hmm.
the dimensions. So we get the data replicated. So this is how you do it in this API. This other API we're seeing down here, it's the same. It's just done with names, which um, I guess these names are very useful for when you're doing constraints, or you're adhesive. You're doing, I don't know if so pmap. You can give like axis names, and I'm guessing they're correlated with this the sharding names, and then you can do uh, certain communication between devices based
the name.
on the name of the axis. So I'm
Hmm.
expecting this to serve that purpose. But here we can do the same trick we're doing up there. So here we're replicating B. It seems that if we omit B, it's the same. And here we can replicate A. So yeah, this has the same logic as we were seeing up there.
Hmm. Makes sense.
Uh, just just that we even have the same color bug. Uh, we get the same kind of logic, but maybe I'd say that the mesh is fixed, and then we just play with the names. This might be a little bit more intuitive. The downside is that you have to create like the mesh and keep it
Yeah,
around.
you play with the logic of how did you name the your axis creating the mesh.
Yeah, I mean, this is not bad. I guess at the beginning of the program you define the mesh, and the mesh is
Hmm.
just kind of the optimal configuration, and and then you'll just be putting data according to the name sharding, and then maybe just because you gave names to the dimension, it makes more sense. Uh, so I think we should stop here. Uh,
Makes sense. But that's cool. That seems for me it's actually it's more than an argument that JAX is becoming really, really, really cool to do parallel programming.
yeah,
So
my I think that the next step, that maybe you can try to do in maybe the next stream is okay. How actually use some of the like features from Pidget, just using this so now JIT is Pidget. So the tutorial has, as it continues, it has this other part where it shows you how to do more complex operations. The one I'm interested is in the constraints. So you can help the JIT program and give it some constraints for some intermediates. So in this case, You say, okay, like uh, this data should at this point have this sharding. So I'm guessing that helps the compiler.
But wait, wait,
Uh,
wait. So the shrouding object, it's out. Ah, okay, it's outside and it's a position of shrouding.
yeah, yeah, yeah.
Okay,
The
makes
thing is
sense.
that I know that this is used within pgit. Well, that now is JIT. When the compiler is doing something dumb, I don't know. It's uh, creating some shardings that are not optimal for the operation. Then what I know happens is that you introduce like a constraint, so it's forced to look for a solution that might make more sense for the operation. It's coded by then the constraint guides the compiler. Um, and I'd be very interested to create like a model parallel program.
Well, I would love if maybe we can think about next week that we can do that way, 8-way batch data parallelism.
Yeah, we can take a look at the example for neural networks, which sort of tries to do this.
Hmm.
My only, I guess, confusion here, or the only thing that I don't like is that the data, which we have here, the data and also the weights, they are always 2D arrays, which is it's not it's not what you get in real life. Like I would love to see like okay how to do model parallel, but with more dimensions. Unclear if the reshape trick we did helps, but yeah, we can explore this maybe in the next stream. Uh, okay, yeah, I think we can leave it there.
No, thank you, Mr. Christian. That has been like a quite the tour. I don't know,
Yeah,
maybe if anyone in the audience have any questions, like something that we might be able to play with it.
be surprised if there was a lot somebody in the audience at this point. But Josh, if you're hearing this, thanks a lot.
Thank you, Josh.
Very useful the comments. So so yeah, let's leave it at this. And okay, I think it was a test. This was our test stream, but I think the format it worked well.
I
Uh,
think that was cool. That was cool. Maybe.
yeah, maybe we can explore some easier things
Well,
in future.
it was the release of Jack, so it was worth a while. There are
Yeah,
50
this was
that
an interesting topic. I think we can continue this saga, but in the future, I would also like to do like basic flax stuff, which I
I
think
think it makes
help
it
more the
also.
regular viewer. Um, Also, yeah, we can do more regular stuff. This was a lot of new knowledge. Um, but anyway, uh,
Thank you very much.
okay, see you in the next one.
See ya.